Hi there, students. This is Dr. John, your physics and math professor, coming to you with another circular motion equation. This is the best attempt I can do at a sketch here. Hopefully you can see what I'm talking about. Here is a kid that has a rock in a slingshot. I'm not talking about this kind of a slingshot, but the kind where you whir it around your head, above your head, or whir it this way. In this case, they're whirring it horizontally, like straight above the head, like this. And the rock is being whirred at a radius. In other words, the length of the string is 1.10 meters. The mass of the rock is 2.0 kilograms. That's a heavy rock. And what we know is that the tension that the rope can take is 135 newtons. We want to find out how fast that rock can move before the string breaks. I've written the question out there for you in the bottom, and then I've just drawn it up here for you again here. So here is the rock. Remember, this is straight above your head, so there's really no sense of gravity. Gravity is down for everything. We're just working about the force of going in a circle. And it's going in a circle like this, and the string is providing a tension. So what happens when you go in a circle? We have an equation for that. And that is, to go in a circle, you have to have a centrifugal acceleration equal to v squared over r. And the idea is, as you're moving here, let's say you're moving in this direction here, like this, and you want to start going in the other direction, you want to start going in this direction, you're going to have to always provide a force like this. Throughout the circle, you're always going to have to provide a force, an acceleration toward the center to change the direction of the velocity. Because the velocity wants to keep on going in this direction, you have to constantly pull it this way. The acceleration you have to provide is v squared over r. And what force would you have to provide? Well, that's just simply this times m. So the force, we call this centrifugal or centripetal force, would be m v squared over r. Let me erase some of this stuff here. Now this here is sort of a theoretical force. It's the force that you need to have. It's the amount of force, the amount of newtons that you need to have in this direction, in the center, toward the center direction, to make this thing go around, to make the circle, the rock go around. It's not a thing in itself. You have to find the thing that created this force. What is it that creates this force? Well, it's the tension in the rope. So in other words, the tension here, tension, I'm going to call this tension T, tension is also a force. So the tension is going to have to equal m v squared over r. Let me just write that down here. The tension is going to be equal to m v squared over r, because the tension is what creates the centripetal force. There is no centripetal force unless there's something pulling it toward the center, and that's what the tension is. So the tension is going to be equal to this. What we want to know is the velocity. We want to find out the max speed. So let's solve for that. So we take the r to this side. I'll just do that right away here. I'll just take an r right over here, and then divide both sides by m, like that. And then we have v squared is equal to that. So I'm going to write that over here. V squared is equal to r times the tension over m. So that's going to give us the max velocity. Let's figure out what that is by plugging in these units here. We have r, so r is 1.01. We have the tension, the maximum tension the rope can do, 135 newtons, and we're dividing by the mass of the rock, 2. So this is going to be about 70 or something like that, because this is about 130 divided by 2, so my estimate is about 70. Let me check my calculator and see what I get. So here I took the actual calculation here. I'm getting 74.25. I rewrote that over here, but remember that's v squared. We want to take the square root of that. So v is equal to 8.616. This would be meters per second. We're nearly done. There's just one more thing that we need to do. Look at this. This has 3 significant figures. This has 2 significant figures. This has 3 significant figures. So let's keep 2 significant figures for this. It's the lesser of the 2, which would be 8.6. So the velocity max, v max, is equal to 8.6 meters per second. There we go. We're done that problem. Does that seem like a reasonable speed? Yeah, it seems like a reasonable speed. I hope that helped. If it did, I will see you in the next video. Bye-bye.